So again, hello everyone. I am Chitish Rimal. I'm Google Developer Expert in Machine Learning, and I'm currently Head of Research at AI for Development. It's a not-for-profit research organization based in Nepal, and we do all sort of projects related to deep learning, which can positively impact our society. So projects related to AI for accessibility, disaster relief and response, and so forth. So all of these projects, they are open source, they are for the community, and they are built so that we can create an impact to the society using all these latest technologies. So if you want to learn more about what we do, you can go to ainepal.org and learn more from there. And without further delay, let's head back to the topic in hand. So okay, so for today's session, we are basically going to break this down into three parts. One is machine learning overview, another is on-device machine learning, and the third part is, which we are all waiting for, on-device machine learning using Flutter. So I'm assuming few things here. So I'm assuming that you are already familiar with Flutter, but you are not so familiar with the machine learning in general, or TensorFlow or TensorFlow Lite and on-device machine learning. So I will be going more on machine learning and on-device machine learning, and at the end of the session, I will go through this, how we can use this on-device machine learning with Flutter and how you can integrate it easily. And we will look into the examples, and we'll look into the sections where you can learn more about it. And I'm also like to share that I'm an expert, or I have some experience in machine learning, but I'm also exploring Flutter, like all of us. So this is my fascinating exploration with Flutter and how we can build machine learning AI applications using Flutter and on-device machine learning. So let's head over to the first step, which is a machine learning overview. So when we talk about machine learning, so basically these terms like artificial intelligence, machine learning, and deep learning, they all sometimes use interchangeably. But the thing is that AI, artificial intelligence, is a big domain. It's a big field, and machine learning is a sub part of this AI broader field. And the task in machine learning, the approach in machine learning, is to train a model that can learn from an examples or the past experiences, and so that it can generalize well, it can predict well to the new and unseen data in the future. And deep learning is also a sub part of machine learning. So basically in deep learning, what we do is we create these models, these intelligent models that uses artificial neural networks. And it's the same as machine learning. Deep learning is machine learning, but in deep learning we use neural networks. And we do that using frameworks such as TensorFlow, which you might have heard, and Keras, which is its high-level API on top of TensorFlow. And generally, in terms of machine learning and deep learning, we usually use languages like Python, C++. And we do that, we build these models using environment like Jupyter Notebook, which is an interactive notebook environment, or Google Colab, which is a freely hosted, free-to-use interactive notebook made on top of Jupyter Notebook, which allows you to utilize all these graphical processing units, GPUs, TPUs, and cloud and cluster for free. So we will be building an application, we'll be building a model using TensorFlow and Keras, using all these different tools and environment, and we'll be running that on a Flutter application. So let's talk about brief about how we build a deep learning model. So there are basically 4 steps to build a deep learning model. So like I said, machine learning or deep learning is a part of supervised learning, where we provide data to the model. So basically what it's doing is that we provide data, and the model is learning from the data we have provided, and and on top of this data we also provide labels to this data, so that let's say if you want to make a selfie classifier, so you might want to provide your photo. On top of your photo, you might also want to provide a label saying that this picture is of my friend, this is of me, and so forth, so that model will know which picture belongs to what. And using that data, we build our model. And in this case, we are building a neural network or deep learning model. So these are the 4 steps that we generally use to build a machine learning model. So first, we take the data, we pre-process them, we make them into a certain format that can be understood by the model, and then we create our architecture, this deep neural network architecture using TensorFlow and Keras, and we train that model using the data we have provided. And after we train the model, after the model learns all these interesting features from the data, and it is able to now predict, given new images to it, then we save the model. So these are the 4 steps that we take to build a deep neural network. So the TensorFlow part is basically, so TensorFlow is a framework. It handles end to end. So that means it can also handle things like handling the data, feeding into the model, and it also handles training the model and creating this architecture, this deep neural network architecture. But in a specific way, when we use TensorFlow, we generally understand it in case of like building a model. So in this 4-step process, let's see this second one where we actually build the model. So here, so this, if you can see this, code, what it does is that it creates, in this first part, it is creating a deep neural network architecture. In this case, it's just a one hidden layer neural network. So you can see in this line of code, we can easily create a deep neural network using TensorFlow and Keras. So the way you do it is you import TensorFlow, and which I will be showing later on in this session. So I'm showing you this slide just to give you an idea what it goes, how we can build this deep neural network using TensorFlow. In this case, I'm using TensorFlow 2.x, which is the latest version of TensorFlow. So using this TensorFlow 2.x, first we create the architecture for our deep neural network. So in this line of code, we are building this architecture here. I am adding one hidden layer neural network, and I'm basically adding one hidden layer and one output layer to this neural network. And I'm compiling this neural network, and I'm training the neural network in this line of code. And right after the model is trained, here in this case, we have trained this model in 5 epochs, that is basically using 5 iterations, given this training data and labels associated with it. We have trained the model, and in this line of code, we have evaluated the model. So as you can see here, in just this 4 line of code, we have constructed a simple neural network which has one hidden layer. We have compiled the neural network, and we have trained the neural network, and in one line of code we can evaluate the neural network using TensorFlow 2.x and Keras. So it's that easy using Keras and TensorFlow to build a simple neural network like this. So, and not only that, in fact, using Keras and TensorFlow 2.x, you can build more amazing neural networks that can do amazing things. So let me share you some of the neural networks, some of the applications of neural network that we might have heard nowadays, and these are all can be built using TensorFlow, Keras, and so forth. So let's talk about one application. So in this slide, as you can see here, we have a lot of images here, but the interesting thing is that these all images are created using a neural network. They are not real images. So there is a neural network called GAN, which is called Generative Adversarial Networks. So using these neural networks, we can create images that look like an actual image. So in this case, we have a dog, we have a coffee cup, and all these interesting images, but they look so real, but they are not. So as you can see, not only a simple model, we can also build neural networks that can do amazing things like that using TensorFlow and Keras. And another amazing example is neural artistic style transfer. So in this case, I have taken an image of Mona Lisa, and I have shown you here, as you can see here, Mona Lisa is translated into different style of images. One is from Van Gogh, one is from another artist. So they are all translated using deep neural networks. So I think this one is a pretty, popular example, and there are a lot of applications and mobile applications that can already do that. So I'm sure you might have heard about this or seen it or use it already. Another interesting application of machine learning which we can do today, which is possible because of this deep neural networks and GANs, is that to understand the different attributes from a human face. So in this case, the neural networks has understood like where the eyes are, where the nose are, what it means to have a smile on a image, what it means to have a sunglass, and they are all trained, like pretty amazingly. And as you can see, a neural network can generate these all kind of images with all these different attributes, and this is pretty powerful and amazing. And another interesting application, so far we have seen application in computer vision, but deep neural networks can also be used in terms of natural languages. So one of the amazing example here is a model called GPT-2, which was released by OpenAI organization. So this model can generate images like the images the model can generate text that are like written by an expert, like a poet, or like a human. So by just reading the text, you might not like recognize or identify that these might be generated by the deep neural network. So we have achieved so much of excellence and accuracy in terms of deep neural networks and what they can do now in today's age. But not only these amazing accomplishments, there are a lot of challenges also associated with these kind of models. So let's briefly talk about what are the challenges that are here. Even though these models are so much powerful and so much accuracy and can do a lot of things that a human can do, these models are fairly large in size. So these models might be in the size of GBs, and they are mostly trained on a cloud cluster with a lot of GPUs and TPUs, and they might be only ran on clouds and clusters. So these are like a big bottleneck or difficulty in terms if you have a smaller device in your possession, you might not train a model that is more powerful like this. And it's obvious that if this model is large in size and that can only be trained or ran on cloud devices, they might be computationally expensive. So one way to address this challenge is using on-device machine learning. So let me briefly share one application that I built using this on-device machine learning. In this slide, you can see there is an app called Cast Recognition for Visually Impaired. So this application is an open source application which is on-device machine learning. So let me give you a brief of a context about this app. So in Nepal, where I'm from, there are a lot of these paper currencies that we use every day. They are not visually, they are not accessible to visually impaired individuals. So by just touching them, you might not know like how much this currency worth, and this is more challenging to the visually impaired individuals. So one way we use to tackle this problem is we build a neural network that can be run on a device, which is on-device machine learning essentially, and that can recognize these notes that a person is holding and play the sound signifying the value of these notes. That way, the person will know, a visually impaired individual will know that how much the person is actually carrying in his hand. So this is one way we use on-device machine learning. So like in this example, basically on-device machine learning means running or training a deep neural network on device. That means the device itself that you are using is responsible for handling input, processing or computing, and producing the output. And these devices might be a cell phone, mobile phones, Android, iOS devices, or IoT devices like a Raspberry Pi. So why use on-device machine learning? Like I said, so using on-device machine learning, there is no round trip to the server. That means the whole model is on your device. The model never leaves your device, and all this computation and handling of input and output, they are done on your device. So there is no latency at all. And privacy, since all the computation are doing on your phone, you don't need to send your data to the server. So you can preserve your privacy, and there is no connectivity issue, as there is no requirement of an internet connection. And that can be, it is also like a portable. You can go to the remote places in the world and you can use this application that do not require any internet connectivity. And since there is no dependency on network connections, it is like assumed like it is less power hungry, because a lot of these power consumptions can come from the remote connection and so forth. So this is why we typically use on-device machine learning. So not only that, there is also like a little bit of trade-off we might have to do if we want to use on-device machine learning. So like I said, all these amazing deep neural network architectures that can generate images, that can generate text and classify all these different images, they are bigger in size. So naturally, if we want to shrink down these large models into a smaller size, we want to set a trade-off. We might be trading off something like accuracy versus latency. So let's say if you want a smaller model, you might want to prioritize which one you want the most. Either you want more of the accuracy or you want less of the latency while running the model. So these are the trade-offs that we might want to acknowledge beforehand before running these on-device machine learning models. So that being said, so let's say what it can actually do. So these models are smaller in size compared to the earlier version of the models that I just showed you. So even though they are smaller in size, even though they can run on devices, they can do many pretty amazing, amazing things, like image classification that we can do in a lot of things. Like in this case, in this screenshot, there is an image that the model can recognize a banana, and it says it has it is giving a prediction like it's a 98.82% sure that this image is of a banana. And not only image classification, the model can also, this on-device models can also do localization. So given the image, if there are two objects, it can properly localize them and give a nice bounding box, where these images, these objects in an image are located. And not only image on this object detection, it can also do pixel-wise classification, that is semantic segmentation. In this example, the model can accurately segment out person from the background. And pose estimation. So given a video or a live camera feedback, the model can accurately detect pose from this input. And this one, a smart reply, I think this one is mostly experienced by all of us. You can experience that in a Gmail app and a lot of mail applications. There are smart reply already, so they can all be done on device. And thousands of productions app already use it globally. So you might be using all of these app already, and they are already using this on-device machine learning in their day-to-day operation. So and not only that, there are more than 3 billion mobile devices globally that use TensorFlow Lite in production. And this on-device machine learning models, they can handle text, they can handle speech, they can handle images, audio generation, translation, content generation, and so forth. They can do all this pretty broad topic already. And one way to use this on-device machine learning is using a framework called TensorFlow Lite. So we have seen how we can easily build a simple neural network using TensorFlow 2.x. And after building a model using TensorFlow 2.x, you can use TensorFlow Lite to convert that model to a model that is friendly to on-device machine learning. So this is the previous slide, and I'm just sharing you so that you can get a bit of a context here. So in typical machine learning approach, we go by these 4 steps. We take the data, we pre-process them, we put them into proper format, and we build the model. We pass that data to the model and begin the training process. And after the training process is complete, we save the model. Now, right after saving the model, we can actually use TensorFlow Lite framework to convert it to a TensorFlow Lite model. So in a broader way, TensorFlow Lite consists of 2 parts. One is a converter and one is an interpreter. So the task of a converter is to convert this neural network that we just created using TensorFlow 2.x Keras library. And using converter, it converts into a flat buffer file that can be used in multiple devices. And on these devices, there are TF Lite interpreter that will run these models, run prediction on the input given to these models on these different devices that can be using a CPU, GPU, and all these different devices. So this is a more broader approach, broader sense of what a TensorFlow Lite is. And TensorFlow Lite can already now use a lot of this advanced architecture. So as you can see here on the screen, there are a lot of advanced architecture that can do image classification, image segmentation, and image to image translation, and all of these interesting deep neural network architectures. And not only that, TensorFlow Lite supports a lot of different languages like Swift, Objective-C, C, and C Sharp if you are using Unity for game development, Rust, Go, and in our case, Flutter, Dart. So let's talk about on-device machine learning with Flutter. So here is a video that will show the end app that we'll be building in this session. So here I can take an image from the app, and by just selecting the image using on-device machine learning, it can classify what kind of image that is. In this case, it's a dog, it's a Labrador retriever, and in this case, the model identifies it as a castle or temple, and all this different classifications. So we are building the simple app using TensorFlow Lite and Flutter. So that will take an image and it will classify them, predict what kind of image that is. So to do that, let's hit step 1. So step 1 is creating the TF Lite model. So the model we are going to build, or the model that we are going to use today, is called is a model that is trained on a data set called ImageNet. So this ImageNet dataset, they have millions of images and up to 1,000 categories. So these images, which are millions in size, are different types and has 1,000 different categories. We pass that data to our neural network and we will train them. So in this case, we have a neural network called MobileNet, which is a neural network created by Google, and this is very friendly to mobile devices. So that is why it's called MobileNet. And using all this advanced architecture, it is actually very small in size and can do image classification pretty fast, even in the like a very old devices that is running an Android phone, that is on an Android phone. What we are going to do is we are using a model called MobileNet, which is trained on this ImageNet dataset, and they have like millions of images up to 1,000 categories, and these categories are like in our application, it can be of a dog, it can be of a bird, like a person or a computer, and things like all these general purpose objects with 1,000 categories. So we are using this MobileNet architecture now in an application that we are going to build using Flutter. So to do that, what we require is 2 things. One is TensorFlow Lite model, and one is a text file that has all the labels, these 1,000 categories associated with these models, with this model. So How do we create this TensorFlow Lite? It's pretty simple. So if you're already familiar with the Google Colab, you can just go to colab.research.google.com and you will be presented with a new notebook environment. There you can simply import TensorFlow, like import TensorFlow as TF. You can make sure that the version that you import is actually 2.x. So one way to do that is using this syntax. So this is written in Python. So this is not in Dart. So if you're not familiar with Python, I think it's a pretty straightforward language and it's not that hard to pick up. So you can say that this, so you can simply import TensorFlow from, first you import TensorFlow using Google Colab. And then right after you import TensorFlow, what you can do is in TensorFlow, in Keras, there is already an approach that you can use this MobileNet model that is already trained on ImageNet dataset. And that can be done in single line of code. So using this line of code, tf.keras.application.mobilenet, you can simply use this MobileNet architecture and download that architecture which has ImageNet weights. That simply means that this model is already trained using ImageNet dataset with 1000 categories. And with that, you have now a MobileNet model, and which can categorize your images up to 1000 categories. And simply using this model, you can convert it into a TensorFlow Lite format using this two line of code. So tf.lite, tf.lite.tflite converter from Keras model, and you pass that model to as an argument, and you convert them and you save them as a tf-lite file. And simple as that. So using this line of code, we can simply import TensorFlow. We load this MobileNet architecture with the ImageNet dataset trained on, and we convert that model into a mobile-friendly version using TF-Lite converter, and we save that file in a TF-Lite format. Simple as that. And you can also access this notebook using this tiny URL here. Let me just wait for it to go away. Yeah. After that, we need labels. So one way you can get labels to this MobileNet architecture is going to this GitHub repo. So for this application, I have used labels from this GitHub repo. So you can also go there and download the labels. And basically they have 1000 categories, 1000 labels, and in there can be multiple categories associated with each one of them as well. So these are the label files, and we just created a TensorFlow format, a TensorFlow model using TensorFlow 2.x first, then using a converter to TF-Lite file. After that, what we need to do is we set up the application. So the process behind setting up the application, and I'm sure many of you are already familiar with this because you might already be familiar with how you can build a Flutter application. So basically we initialize the project, we create a folder that has our assets, that is this TensorFlow Lite and the labels file associated with it. We install the required packages and we modify. For the sake of this application, we are using Android application here, and I'm not running this application on iOS device. So for this application, we are going to modify a little bit of this build.gradle file, and so that it can be run on Android devices. So in this application is I have only tested on Android devices. Okay, so first thing first, install Flutter. So I'm sure if you have already installed Flutter, you can skip this process, and the most easy way to do this is go to this flutter.dev and go to this get started section and install all these steps, follow all these steps and install on your device. And after that, you initialize the project. So if you have already installed Flutter, if you are using Android Studio, which is in my case what I used, so you might see something like this start a new Flutter project option, and by just clicking on it and following this wizard, you can create a Flutter application. So right after creating this new Flutter project using Android Studio, what you can do is create a directory inside this main directory. So this directory name is assets here, and so you can simply create a directory there called assets, and you put all your label files, and a MobileNet.tf-lite file there. So after that, you install the packages. And the way you do it is go to pub.dev, and in this case we are using TF Lite package, which has version of 1.0.5. So you can simply go to this URL and install this package. And another package that we are going to use is Image Picker. So basically you need two packages, two external packages here. One is TF Lite and another is Image Picker. So the way you do that is you open your popspec.yaml file, and under dependency you just write tflite and specify the version, and image picker and specify the version. And at the bottom of this YAML file you can also add a section like assets and specify where your assets are. So after editing your YAML file, popspec.yaml file, you need to edit this build.gradle file. So this build.gradle file is located in Android under another folder called app, and inside that you might find this build.gradle file. And inside this build.gradle file you want to modify two things. One is you need to make sure that the minimum SDK version of this is 21. So by default it is something like 16 most of the time, so you edit that 16 into 21. Then after that you add this two line of code, that is AAPT options, and you specify for TF Lite and Lite format files you do not have to compress them. So we are just basically specifying our application that we don't need to compress them while building the application for our mobile devices. So after that, what we need to do is we create the application. So creating the application is pretty straightforward. You import the packages, you create the stateful widget, you create a method to load your model, you create methods to run your predictions, you create methods to load your specify how you want to load your images from your phone, either from gallery or camera, and you basically modify your build method for your UI of your liking. So let me give you a brief overview how this app will look like and how this app is created. So here, as you can see, I think I hit something. Okay, great. Okay, so here, as you can see, we have app bar, which is specify the title of our application. We have a text widget that will show the prediction that our model just did, and we have image widget that will show the preview of the image that we have selected, and we have basically two buttons that will specify from where we want to take our image, either from a live camera or a gallery, which is on your device. So if you want to see the tree structure for this Flutter app, what we have is a material app. Underneath we have a scaffold, and underneath we have app bar and a list view. And inside this list view we have two things. One is for prediction and one is for image preview. And we have a row which basically has these two buttons. So let's import packages. So for the sake of simplicity, I'm doing all of these things in a single file, that is this main.dart file. So by just examining this file, you can now basically modify it and put it in a different files maybe later in your project. So you can absolutely do that. But for the sake of simplicity, I have used all this code inside a single file so that it will be like easy to follow. So the thing we need to add here is that we need to import material.dart, services, IO, and these two external packages that we just installed, that is TF Lite and Image Picker. And after that, we create a stateful widget. And the way for this application, I have created a widget called detect, and I have basically pointed that to this run app method, and if you're like me, if you don't like this debug banner in your app, you can basically turn it off using this parameter, so it's just that. And inside this stateful widget, this detect, we have all these private variables. That is a variable to store the image that we are going to select, either from camera or gallery, a variable that will store width and height of our images so that we can properly show them as a preview in our application, and recognition variable that will basically hold whatever the model has predicted on this image that we have just selected. And these are all done in this main.dart file. And after that, we create a method to load the model. So in this case, I have created a method called load model, which is a synchronous model. So basically using this tflight package, we can simply say tflight.load and specify the path where our model is located. In our case, it's in assets folder. So assets mobile.tflight, which is the model that we just created earlier, and the labels associated with it, which is the labels.txt. So after that, after you create this load model method to load your model, we create methods for our prediction. So in this case, I have created two methods. One that will actually run prediction on our image. So in this case, this predict method. This will basically take image as an input, and using this tflight.run model on image method, it will take this image, specify its path, and basically pass it to the model that we just loaded. And after that, the predictions will be stored in this recognition variables, and we just update our private variable using the setState method. After we just receive the recognition, and you might also want to print this recognition on a console, so just to check if it's working or not before actually using the UI. So you can absolutely do that. So using this method, what it is doing is that it is taking input as an argument, passing that image to this run model on image method, which is on this tflight package, and it is just taking these predictions out of this image. So it's simple as that. In this case, you might see all these parameters. So they are basically these parameters to do normalization on your images, which is the task of data pre-processing. And if you take, like any of these basic machine learning courses or tutorial, like data pre-processing and normalization is a crucial step there. So these parameters, these arguments are basically passed to do this normalization on this image. And here, as you can see, there is this argument called num results. So basically what it means is that by just passing the image to your model, the model can predict up to 5 predictions. That is, it will on the top of the prediction, it will predict something that is absolutely sure of, and down under, the prediction will be the model will be little less sure. So you can specify how many prediction you want in a single image. In by default, it's set to 5, but you can also set it to 1 or 2. In my case, I set it to 2. So basically, if I pass image to this model will give prediction. It will give 2 predictions, and I will just take the prediction that is absolutely sure of, that has highest probability. So let's say I pass an image like an image of a coffee mug, and if this model is like 90% sure that this image is a coffee mug, I will take that prediction. And there is another prediction on the same image which is like 10% sure that this might be of a different thing, so I will just discard this. So I'm just taking 2 predictions out of images. So this is how you specify that. And after this, there is another method that I also created for this prediction. So what it does is that it basically takes the image as an input, it passes that image to this predict function that we just created, and after the prediction is done, we will basically take this height and width of this image that we have just selected and save it in our private variable. And on top of that, we also save that entire image in our private variable. So basically, this send image is just handling input to this predict function. So we created 2 methods to do prediction. One that will take the image and that will pass this image to this main predict function. And after the prediction is done, we will basically take height and width of the image that we just selected, that we just passed, and we just store it in our private variable. After that, we create methods to load image from gallery or camera. So it is very straightforward process. So using the TF-Lite. After this TF-Lite package, we also imported another package called image picker. So by using image picker, we can easily select from where we want to take this image input. So in this case, we just specify two functions here. One function will take image from gallery and one from the camera. So here image picker will basically take images from gallery. So you just specify source as gallery here. Simple as that. And you just, after just taking the image from the gallery, you just pass it to this send image function that we just created earlier. And this send image function will later pass this image to predict function to do predictions. Another function is select from camera, which is similar. You just change the source from gallery to camera, and you do the same, send image to the send image function. Now, after that, you modify the init state method. So while you instantiate your widget on a screen, you might want to load your model. So this could be the first step you want to do while loading the widget on your screen. So to do that, you just basically run this load model function inside this init state. After that, you modify this build method for your UI. So in this case, I have also included this little mockup to give you idea how we are designing things in our UI. So before handling the build method, I have created another method called print value. Sorry. So what it does is that before we select any image, there could be no prediction. So if I haven't selected any images or passed the images to the model, this section, this prediction section, will basically be empty. So here, if the recognition is null, just print out the empty text. So there could be no predictions. It's just an empty space. And if I have selected an image and if the model could not recognize the image, I will just print out like I could not, the model could not recognize the image or something like that. And if the image is already predicted and the model already recognized the image, we can basically print the recognition as this. So all these recognition are stored in this recognition variable, and using this array, multi-dimensional array, you can basically, take the label, the first label, which is the most, confident of this model is. So in this case, I have taken two prediction, like I showed you in the load model, method. So here I have just taken the first prediction. That is, the first prediction is always like the model is more confident on. So I have just printed the prediction that is the model is more sure of. So in this case, if the image is already passed to the model and if the prediction is already made, basically say something like prediction colon and the prediction, that is the class name associated to, that could be associated to the image that I have just selected. So it's simple as that. So using this method, I have just handled that. Then after that, we just go to the build method. In this case, what I have done here is that after, if I have selected the image, I might want to ensure that the image width and height might be proportional to the screen size of my device. So to do that, I have just basically calculated ratio of width and ratio of height and just resize the image so that it can be fit in my UI. And it's simple as that. So in this case, I have just used media query context and get the size of media query context to get the size of, the screen size, width and height. And basically I have resized the image that I have selected to proper height and width so that it can be accommodated inside the screen. After that, we return the build method with a scaffold, and inside the scaffold we have app bar that basically says the title of the application. The title can be placed in center, and there is a and we can basically run prediction here. So this print value that we have already created earlier, that will print out the prediction for these images that we have selected. And at first, when you just open the app, you might see something like select image from camera or gallery images. So before I select any image, there could be no preview. So in that case, I have just printed out a text widget that will say something like select image from camera or gallery. So and after I select an image, then I will just basically preview the image there. So this basically handles that. After that, we create a row with two buttons, two flat buttons with icons, one for camera and basically perform select from camera method, and another for gallery, select from gallery method. And with that, we completed the whole Flutter application, which uses TensorFlow Lite model. So the preview, as you can see, which you have already seen earlier. So this is the app that we just built. So you just select image either from camera or gallery, and it will run the prediction on it. So it's a very straightforward process, and it's very simple to construct something using Flutter. You basically create a TensorFlow Lite model, you put it in an asset folder, you do proper modification, and you create the application and you run it. And it's a very straightforward process. So the whole application is already available on GitHub. So you can go to this GitHub repo. Basically, you can search my name in GitHub and go to this classification Flutter TF Lite repo, and you can download the code. You can look at it. You can modify it and whatever you like. And another app that I want to show you is which also does on-device machine learning, but in this case it does image segmentation instead of classification. So in this case, I will select an image from my gallery, and this image will be segmented out, like in the earlier example that I showed you on a slide. This model will run on device, and instead of classification, it will do semantic segmentation. So it will basically segment out where I am located in the image. So you can do that to remove the background on your photo, and all this interesting application you can do. So this application uses another model. So in our earlier case, we use mobile net architecture, but in this case, it uses something called Deep Lab. So this Deep Lab model will do semantic segmentation on your device. So if you want to learn more, there is a repo called Awesome TF Lite, and where you can see there are a lot of Flutter applications, a lot of Flutter code already. There is a one called object detection using Flutter. So basically, it uses Flutter and TF Lite to do object detection. You have already seen image classification and image segmentation. You can also do object detection using Flutter and TF Lite. And there is also another repo called segmentation Flutter real time. So in this case, in our earlier case, we specify what kind of image we want to do segmentation on. So what we did is we select image from gallery or camera and then run the segmentation. In this case, in this segmentation Flutter real time, it will basically run camera on your device, and you can see this live camera feed on your device, and it will run this segmentation model on each frame of your live camera feed. So basically it's a real-time thing. So you can play with the code, you can see the code there with this awesome TF Lite repo. After that, if you want to take a course, if you want to learn more about TensorFlow Lite, you can take a course here in Coursera, device-based models with TensorFlow Lite, and it's a part of TensorFlow Data and Deployment Specialization. There is also another course on Udacity, which is Introduction to TensorFlow Lite. And you can learn from a YouTube channel, TensorFlow YouTube channel, and TensorFlow official website, which is tensorflow.org. And of course, if you want to learn more about Flutter, I'm sure you already know that, which is flutter.dev. And I have seen that there is one online class which is free for now until July 8, and this sounds very promising, and I might actually take it as well. So it's kind of cool, So, and on top of that, if you want to utilize a lot of these different models that we just seen, like a Deep Lab or Mobile Net, you can actually go to TensorFlow Hub, which is TF Hub. So TF Hub is a place where you can download all these pre-trained models and use it in your application. So there are a lot of devices, a lot of models that will do segmentation recommendation, object detection, and a lot of cool things. Even this text classification and NLP stuff. So you can do that using TensorFlow Lite. So that's it. Thank you so much. If you want to reach out to me, here's my Twitter handle, my email, my LinkedIn. Thank you so much. And I think I'll be answering questions now. Okay, how can one start his or her journey of TensorFlow? Okay, so there are multiple ways you can take, of course. This is like the thing with machine learning, the thing with machine learning is that there is no straight path. So what I have done is that I have taken courses earlier, like a couple of years ago. I have taken a lot of courses from Coursera, and I have watched a lot of videos on YouTube. So that is the number one thing. So if you want to learn machine learning or even TensorFlow, so before learning TensorFlow, you might want to actually learn basics behind machine learning and deep learning. So to do that, I would suggest you complete one full course first. So either you take it from Udacity or Coursera, or even do a lecture series on YouTube, whatever you like. There are a lot of free courses, there are a lot of approaches now. So just take one and finish it, complete one. Then you will know a lot of this broader idea about machine learning and deep learning and AI in general. And then pick a framework. Either you take a TensorFlow or a PyTorch or any other. Just take a framework, and then it will be much easier for you to go on this path. So you know the basics, you know the concepts, and you just take a framework and you start building projects. So first step is take a course, complete it, and then only you can move forward. Okay. An advantage is power consumption due to power hungry connectivity, but ML takes much processor, right? Other advantages. Yeah, so the typical machine learning model, the deep learning model, they are pretty big in size. They are computationally heavy, but this on-device machine learning models, they are smaller in size, and the layers, they are like different than the regular neural network. So they are designed in such a way that is more computationally, feasible to run on low-power devices. So in comparison, it will absolutely take a lot of power compared to regular processes, but compared to the bigger model, it will be less power hungry. And if you avoid this latency, all this network connectivity issue, it will be less power hungry as well. Why an internet connection is not necessary or never. Oh, thank you so much. Hello from Nepal as well. Well, the on-device machine learning model, they are actually placed on your device. You don't need an internet connectivity to call all these predict functions on your mobile models, all these models. So basically, when you build the app, the model is there. So you don't need to call any external machine learning models that is located elsewhere. You are basically passing the data to the model that is already placed in your device, and all this computation and prediction are done on your device. And that is why you don't need internet connectivity. So basically, it's on your device. You don't need to connect to the internet. Namaste, Satish. Greetings from India. My quiz is how Uber using it. I have no idea. We don't have Uber here. So, but Uber, there are a lot of assumptions that I can make, but I might not be the proper person to answer that. So I'm sure you might also guess some of these applications like pathfinding prediction, or like calculation of this a lot of tariff, or like locating all these new drivers around and things like that. That can be possible, but I'm not a proper person here to answer that. I'm really sorry about that. What would be more recommendable to do first, create ML model or application? It depends. If you are if you are someone who is from a startup background, and you might actually want to start an application first, and start collecting data and labeling your data for your machine learning model. And when you have a proper data set, then go on to create a machine learning model. But that being said, you might want to, like keep in mind this whole conceptual idea. If you want to create a machine learning model, you first might, conceptualize how you actually use that machine learning model on your device, on your application. So it depends on application and the way what you want to do, but basically you first need to, be sure of what actually your machine learning model does, then maybe figure out a way to either create a machine learning model first or application. Yeah, absolutely. I think TensorFlow Lite is already being used in machine learning MLKit, and I think there is another approach to use MLKit, which is a little bit different than that what I just showed you. But I think the steps or the things how it load the model or prediction is kind of similar. Yes, it absolutely uses TensorFlow Lite. You can actually use your custom TensorFlow Lite model using MLKit. Wouldn't there be a breach of privacy on using more models like MobileNet? Well, your data never leaves your device. So if your device is already compromised, then there will be of course issues. But in case of like data privacy, where the data leaves your device and stored on a remote server, that will not be a case here. So MobileNet is on your device. The prediction are done on your device. Your data is on your device. So your data never leaves your phone. So I don't think there will be a breach there. Well, you can find that on TensorFlow Hub, HUB Hub. So you just Google TensorFlow TF Hub, and I think the website is tfhub.dev. There you can find a lot of this pre-trained model that can do amazing things already on images, on text, and a lot of different applications. Great, thank you. Is it possible to retrieve intermediate level library using TF-Lite in Dart? I'm thinking about it for the sake of visualizing them. I'm not sure about Dart, but you can actually do that on Python and using Colab and MobileNet model. So the step that I just showed you to create a TensorFlow Lite model, what you do is like you go to Google Colab, you load this MobileNet architecture, and then explore all these intermediate layers and their activations and so forth. You can do that in Python, but I'm not sure about Dart. I have to look it up. How do you level up your skill in ML? Once you are able to build an ingredient, what's next been working on? Okay, once you're able to build and integrate models, what's next beside? Okay, so there are a lot of steps that are, you need to basically evaluate your model. So the biggest level up is that how do you construct your model, how do you get the data, how do you clean up your data so that the model can do proper prediction on it and figure out if the prediction is actually like if it actually makes sense. And there could be a multitude of use cases, and there could be a lot of repetitions, but the more you build your model, the more you label your data set, the more you integrate into your application, you will know for sure that what is the more optimized approach, so in this case I have just used one machine learning model, one TensorFlow Lite model, but in your case there could be it could be a bigger application where there could be 10 TensorFlow Lite models running on your phone, which handles like predictions and inputs side by side. So that could be a next step, and designing all these different machine learning models. One can take an image, one can take text, and one can do generation, one can do prediction, and all sort of things, and working them in harmony, and making sure that they do proper prediction on your production ready application. That is, I think, the biggest challenge is so I think there are a lot of things. I think it's not that easy, you know. So the application that I have used is quite easy because the model that I have used is already pre-trained, you know. But it's a very painful process in reality. You might not get the proper accuracy, and even the size could be bigger, which might not fit into your application, and it could be, it can crash your application and things like that, you know. So there are a lot of hidden things that you will explore, you know, like uncover once you start digging in. And I think in this case of machine learning or deep learning, you are not you know, like you are not satisfied. It might not be the correct word, but you just you know, go on to learn more and more and more, you know. So you are never finished there. So I don't think there is always level of options. In short. How you started going? Well, so is it for me particularly, or is it in a broader sense that you want to want your answer in? So I'm a little bit confused here. So is it for me? Is there any way to answer this? Okay, so okay, okay. Sorry about that. Okay, so what I did is that I come from a software development background, so I'm already familiar with full stack development, software engineering in general, you know, all this UI, UX, and the full back end and full front end stuff. And picking up machine learning as a career path, I took it from a perspective of a developer rather than a machine learning a scientist or, you know, researcher. So the way I learned is that by doing projects, by doing a lot of these end-to-end tutorials using frameworks such as TensorFlow and Keras. So I took a small course on machine learning and deep learning, get the overall idea on how things work there, you know, a little bit of math, a little bit of concepts behind all these different things, and then just basically jumped into TensorFlow, start reading codes on GitHub, you know, and doing small projects with TensorFlow and things like that. So if you go on repeating this process like for a year or 6 months at least, you know, you start to know the things, you know, and you get to know how how the things are done in machine learning, in the world of machine learning and AI, and basically you work on projects and things like that. Do you have any channel or tutorial guides? I have a Medium publication which is called Deep Learning Journal. So if you just go to medium.com and type my name, which is Kshitij Rimal, and you might see a lot of blog posts that I have written there. So I have written a lot of basic tutorials on deep learning, machine learning using TensorFlow. So you might want to go there. I don't have a YouTube channel yet, but I have few videos on YouTube, but it's not from my channel. It's basically interviews taken of me, you know, some of on my projects, but I don't have a YouTube channel, but I have a Medium blog.